I will continue with example 2, and as you can see, the graphs of sine of x squared and sine of x are done. I'm just gonna show you sine of x squared and look at the behavior, especially around 0. And the one in blue will be sine of x squared. Notice how sine of x squared, sine of sine square of x, the entire graph is above or intersects the x-axis, and it's because it's a quantity square and it has to be 0 or positive, whereas the sine of x squared is still the outer function would be the sine, so therefore it still varies from 1 to -1 on the y values. So big difference, these two functions are not the same. This is the way that you will see it on your calculator. Your calculator has no way of putting this little 2 right after the sign, but that's how we write it on paper, and this is how it looks using a computer or a calculator. Going back to the problem, part A, the outer function is sine. And the inner function is x squared. So as long as that's clear, chain rule is a piece of cake. I'm trying to find y prime, or df over dx, or dy over dx. So first I'm going to take the derivative of the outer function. As we saw before, that's cosine of x. But I'm not going to write cosine of x because I have to evaluate it at the inner function. And that's going to be multiplied by the derivative of the inner function, which is 2x. Writing it nice and pretty, 2x cosine of x squared. For part B, the outer function, it doesn't look like it, but it is x squared, or any number to the second power. That's the outer. And the inner function is sine of x. So again, y prime will be the derivative of the outer function evaluated at the inner function times the derivative of the inner function. So derivative of the outer is 2x, but I'm not going to write 2x, I'm going to write 2 times sine of x times derivative of the inner function, which will be cosine of x. Writing this 2 sine of x cosine of x. Now, if this was a multiple choice on either exam, or if you look at an answer key, you may see this, or you may see the equivalent, which is sine of 2x. And this is one of the trig identities that we have worked in the past. Sine of a double angle is 2 times sine of half of it cosine of half of it. But either way, if your answer ends like this and it's an open-ended, it will be fine. Unless, of course, you have some other expressions with trig that you can cancel out as sine of 2x. In that case, you will need to recall that property. But other than that, you probably can end there. So don't worry. Now, the book talks about several chain rules for different rules that we have previously studied, like how does the chain rule apply to power rule? How does the chain rule apply to, what will be the other one? Well, I don't remember, but it just talks about the chain rule interpreted and applied to different other rules that we've learned. But essentially, everything is the same. So I'm just going to stick with outer and inner. And in case we have 3 functions applying, then the same logic applies, like the one that is outer, and then the one that is in the middle, and then the one that is really in the at the heart of the function. Okay, so again, we only have two functions. The outer function, or the last thing that happened to x, was being raised to 100. Sorry about that, that was my dog. Okay, so the outer function is a number raised to the 100th power, and the inner function would be a number cubed minus 1. So to take the derivative, I just have to take the derivative of the outer function, which will be 100 times that number to the 99. But remember that that number, so remember, evaluated at the inner function times the derivative of the inner function. Remember, when I'm taking the derivative of a constant, that's 0. And after that, just write it in nice and pretty. For example 4, some people will be tempted to apply the quotient rule because you see a division. But let's just look at what we have on the denominator. It's simply a quadratic function raised to the power of 1/3, or the cubic root. So this is easy to be rewritten as a power function. So I'm going to rewrite f of x as x squared plus x plus 1 to the 1/3 because of the cubic function, but because it was on the denominator, it gets to have a negative sign. That means reciprocal. Okay, so now I'm ready to identify what's the inner and the outer function. You can pause the video so that you can see if our answers match, or if you are still learning about this, then you can just leave it and listen to my beautiful voice. The inner function would be the quadratic. So notice how when I'm writing the outer function, I'm not writing it evaluated at the inner function, simply because I want to know what happened to x. The first thing that happened to x is being a quadratic function. It's being raised to the second power, and it's added by itself, and it's added by 1. So that's why this is the inner function. It happens first. And the outer function is what happened last. After you get all that answer, it's being raised to the negative 1/3. So the outer function is just raising to the power of negative 1/3. Now to find f prime of x, I need to take the derivative of this function, but evaluate it at the inner function. So for exponents, this becomes the coefficient, and then the new power is 1 less than that. So minus 3/3, that will be negative 4/3, and evaluated at this function times the derivative of this function. This will be 2x, this will be 1, and this will be 0. Everything between parentheses, because you don't want to say that you're adding x to this product. And then you just write it nice and neat. F prime of x equals negative 2x plus x, x squared plus x plus 1 to the negative 4/3, and everything over 3. You don't want to solve this out because, first of all, it's very hard. You have a cubic root here in the denominator, so don't think that you can just double distribute and try to simplify something. That's not the case. Always pay attention to the exponent. But not only that, this is already factored, and if we were to try to find zeros on f prime to see where f will have either a low point or a minimum or a maximum, then this is just perfect to equal 0, already factored. So don't do it out.